Hello and good day, Algebra. We have reached the culminating objective of Unit 3. Lots of POs in this one because you pretty much need all of them for success in PO24. You need to understand slope-intercept form, you need to understand function tables, you need to understand the slope equation, all this stuff. You need to understand how to move terms from side to side. Okay, it all comes back in PO24. Jack? You with me?
Yes.
Excellent. Okay, so we're going to start by defining yet again and summarizing everything to do with slope-intercept form. I don't know why I put 2 lines for this. Slope-intercept form is just y equals mx plus b. I don't know, but maybe I had something else in my head when I wrote it, but there it is. Okay, and we've worked frequently with the m and the b. We know that the m is the variable for slope, and the b is the area or the variable for the y-intercept. Okay, and we've also talked about the x and the y, and we kind of at that time said, well, we'll deal with that later. Okay, so who can remind us what x and y represents in this equation? So far, all we've really cared about are the slope and the y-intercept, slope and y-intercept. But what about x and y? What do they represent? Noah.
The vertical and horizontal on the graph.
Okay, it has to do with that, right? We have this is a graphable equation because it has an x and a y variable, which, you know, we use the x and the y-axis to plot the points. What's that? What do the x and y variables actually represent? Like, what numbers could we plug in for them if we wanted to? Arlene?
Ordered pair numbers.
Ordered pairs, right? That work in this equation, okay? So the y variable is the y value, this one I should put 2 lines for, of any ordered pair on the line, okay? The y value of any ordered pair on the line. And then the x variable is kind of the same thing, only it's the x value of any ordered pair on the line. Okay? The y variable is the y value of any ordered pair on the line. The x variable is the x value of any ordered pair on the line. And we haven't really used x and y too much yet. Okay? Today, though, we are going to be using slope-intercept form for its fullest potential. Not only will we care about the m and the b, but the x and the y as well. Okay? We haven't really cared about them yet. Like, to graph an equation, you don't need to know what x and y are. You only focus on the slope and the y-intercept, right? To convert it into standard form, slope-intercept form, we haven't really talked about it. But today we are. Damien. Sure. Okay. All right. So your directions are, for the rest of the objective, says using the given information, write the equation on the line in slope-intercept form. So our answer for every single one of these is going to be the equation on the line in slope-intercept form. But I want you to look at how the information is presented to you. Okay? In the first 3, I give you the slope and the y-intercept directly. Here's the slope. Here's the y-intercept. Write the equation. Okay? In the next 3, I give you the slope directly and an ordered pair. But what do you notice about that ordered pair? Joey?
It's got a 0.
It's got a 0 for the x value, which means what? It's the y-intercept. So I'm giving you the y-intercept, again, directly, but I don't name it like I did in the first 3. Okay? But then on the second page, things get interesting. Because now, folks, now I'm giving you the slope directly, and I'm giving you an ordered pair. But what can you tell me about that ordered pair? Jack?
It can be graphed on a line.
It can be graphed on a line. But what is it not? It's not the y-intercept. Okay? So the first page is kind of, we've done that before. Here's the slope, here's the y-intercept, write the equation on the line. The second page is where things really get fun. And then I go from giving you the slope directly to just giving you a table and saying write the equation on that line in slope-intercept form. And then I go from a table to say here's 2 points that are on the line, write the equation on the line in slope-intercept form. So my point is that I can present you the information in lots of different ways. Here's a slope, here's the y-intercept. Here's a slope and a point that is the y-intercept. Here's a slope and a point that's not the y-intercept. Here's a table. Here are 2 points on the line. Regardless of how it's presented to you, your job is to still write the equation in slope-intercept form. Which is why there's a really wordy way to basically remind you that you need to understand all parts of slope-intercept form. Everything that we've done so far during the unit. So let's just take one example for each of these, just to kind of get a look at it, then we'll pick it up after break heavily. If I give you the slope and give you the y-intercept directly, what's the equation of that line in slope-intercept form? Ideally, more than 6 hands would be in the air, but I'll take what I can get. Sophie.
Y equals 5x minus 3.
Right. Right. Here's slope-intercept form. All we need to write it is the slope and the y-intercept. Okay. You get the slope, you get the y-intercept, you can write the equation. I tell you the slope is 5. I tell you the y-intercept is -3. Boom. Done. Okay. We've done that before. Right, that was back in I think number 21. Okay, let's look at the second one in the second row, kind of the next type. What's the equation of this line in slope-intercept form? Joey?
Y equals 3x plus 1.
Y equals 3x plus 1. Okay, again, I give you the slope directly. And this time, like we talked about, you know that's the y-intercept because the x value is 0. So the y-intercept is pretty much given to you directly again, but not named. Okay? Now we get to the second page. Ooh. Ooh. All right. Here's slope-intercept form. How are we going to write the equation of a line where you are given the slope, right? I'm telling you the slope is 4, but then I give you an ordered pair that's not the y-intercept. It's on the line, it says passes through, but it's not the y-intercept. Alex?
Is it y equals 4x plus 2?
It's not going to be 4x plus 2 because this is only going to be the y-intercept if your x value is 0. Okay, if your x value is 0. Any other thoughts? Noah?
2 over 2.
Sorry?
Y equals 4x plus 2 over 3.
No, not 2 or no, nothing like that. Decent guess though. Jack?
3x plus 4 over 2.
That's creative. No, that's not it either. Here's what you do. You have another guess? You want to try?
Y equals 4x plus -1.
Nope. Well, wait, how'd you get that? I shouldn't directly say no.
2 minus 3.
Oh, okay, no. Alex.
Y equals 4x plus 1.
How'd you get that?
So, I made my own graph,
Oh, fun.
and then I drew a line.
Okay, so you can go freehand style, right? You can draw your own quarter plane. You can plot that point. You can eyeball the slope, see what you come up with. Maybe you're right. I don't even know. We'll find out. But drawing a quarter plane is not the most efficient way, especially if your ordered pairs get like -4, 35, things like that. Okay, Red, your hand was up next.
Do you change it to standard form?
Ooh, good thought. Change the standard form? No, you wouldn't go that route there. But at least you said something nappy, right? Arlene?
The 3 over 2 in the finding slope equation, and then you write 4 over 1 as the output.
I think we have ourselves a winner. I think, if I interpret what you said. So here's what we do, okay? Slope-intercept form has 4 variables, correct?
Yeah.
I gave you the m with the slope, and I gave you
An ordered pair.
an ordered pair, which represents x and y in the equation. So if we know that 3, 2 is on the line, we can take this ordered pair and we can plug in 2 for y. I gave you the slope, which is 4.
Oh my God.
We can plug in 3 for x.
What?
And because we now have 3 of the 4 variables, we can solve for b. Okay? We can solve for b. So when I said earlier we hadn't really cared about x and y yet, now we care about them. We need to use this ordered pair, which are values for x and y because it's on the line, plug those numbers into our slope-intercept form equation to solve for the variable we don't know. I'm going to write this again up here just to give myself a little bit more space. Okay? Ellen.
Is it?
Let's work through this together. What would your first step be to solve for b here? How do I find what? I took these numbers here, 3 and 2, and I plugged them in for x and y in the equation, along with my slope. Okay? So how would I solve this now? Ellen, what would my first step be?
Do 4
Boys? Shh.
do 4 times 3 and
Yes.
see what you have to get from that number to down to 2.
Okay? So 4 times 3 equals 12. And now to solve for b, it's a one-step equation. I can subtract 12 from both sides. Cancel it out. Solving a one-step equation with addition and subtraction. Right? Opposite operations, railroad tracks. Right? If I want to get b by itself, since I have a positive 12, I subtract 12 to cancel it out. Right? And that leaves me with negative 10 as my value for b. Okay?
That was scary.
So, my equation in slope-intercept form then, my final answer, right? Because solving for b only helps me get to my final answer. My final answer is y equals my slope of 4 times x, and then my b value of negative 10.
Wow.
Right? Why?
And the end part, when 2 equals 12 plus b, you have to do the railroad tracks and it's pretty easy.
No, if you can do it mentally, then you can do it mentally, right? But I had some people looking at me with some confuzzled faces like, how did you? So I'm reminded of the concept. Okay, but again, that's where if you're not showing work, a lot of times people put b equals 10, right? Because they don't actually show the act of subtracting 12. They take in their head 12 minus 2 instead of 2 minus 12. Just be careful with that. Okay, just be careful with that. Let's look at a table example. Again, we'll come back to this after break. So there's no homework. If you don't get it yet, don't worry about it. This is just kind of an intro to it.
Is this homework or not?
No, we just said that. You just said it's not homework.
Hippopotamus, you want to be dirty.
You gotta listen.
Okay. The first table here. We need to write our equation in slope-intercept form, which means we need to find the m and we need to find the b. The m is not explicitly given to you. I'm not telling you slope is this. How do we find a slope using a function table, Max?
You see like how much it goes up on the x side and then that goes on the bottom and then how much it goes up on the y side?
Yes. Remember that the definition of slope is change in y over change in x, right? So we look at this change in y plus 4. From 5 to 9, plus 4. From 9 to 13, plus 4. Do you remember doing this?
Yeah.
Back in 18 or something like that? 17? We look at our x change from negative 3 to 0 is plus 3. 0 to 3, plus 3. 3 to 6, plus 3. What's our slope?
4 over 3.
4 over 3. Change in y over change in x. Right? So we can plug in 4/3 in for our m variable. How do we get the b? Christopher, was that a hand up? No? Arlene?
For this one you use the ordered pair 0, 5.
Oh, nice find, Arlene.
Whoa, we got it,
In
right?
the spirit of 1,000 Christmases, I give you the y-intercept. Okay, and being able to look at that and recognize, how did Arlene know that's the y-intercept?
It's 0.
Because x is 0. When your x value is 0, it's the y-intercept. Now, you look at the other two tables, and there's no, so we'll talk about that after break, right? But for this one,
Hooray!
That helps a lot.
there's our equation. Okay, we had to use the table, boys. We had to use the table to find the slope by looking at that change in y over change in x. You see how everything from the unit comes back now? Okay,
Yeah.
this is like the Bowser of Unit 3, right? You went through all the worlds, you beat all the Koopas. Now we're at the Bowser. Right? We need all those skills from past worlds. Okay? Let's look at one example from the last group. There isn't, and we'll talk about that after break. Thanks for following along. Okay. Let's look at the first one here. Passes through 6, 5, and 4, 9. Again, for slope-intercept form.
Oh, I know this.
We're looking for the slope. We're looking for the y-intercept. Neither one's given to you. Neither ordered pair has a y value of 0. Not helpful, right? The slope is not explicitly given. Why? What do we do?
Y second and Y1.
Yeah. We actually have a formula, folks. We actually have a formula that if we know two ordered pairs will give us the slope of the line. Right? y2 minus y1 over x2 minus x1. So we do that, and we get 9 minus 5 over 4 minus 6. y2 minus y1 over x2 minus x1. 9 minus 5 over 4 minus 6. That gives us a positive 4 over negative 2, or ultimately a slope of negative 2. Arlene.
When finding the y-intercept, can you use either ordered pairs?
So now that we've got the slope, we've got to find that b. The y-intercept is not given to us. So Arlene's going back to what we did previously, and since you've got two ordered pairs on this line, she remembers that we're going to have to plug those values in for x and y to solve for b. And she's asking, does it matter which one you use?
No.
Because they're both points on the line, should it matter which one you use?
Yes.
No, and it doesn't.
Yes.
You use either ordered pair, you will get the same value for the y-intercept. Because they're both ordered pairs on the line, they both work in the equation. B will end up being the same for either of them. So, Arlene, do you want to use this one or that one?
That one.
6, 5.
This or that?
This.
Six,
Which
five.
this and that are you talking about?
This one or
This
that
is
one?
this is 6 bit.
This one?
Yeah.
This one. All right. Arlene wants this one, which means we're plugging in 5 for y,
Yes, me.
right? So that's the y value of the ordered pair. And we're plugging in 6 for x. That's the x value of the ordered pair. And we're solving for b. So if you remember, our first step is to multiply that negative 2 times 6. That gives us negative 12 plus b. And then moving that negative 12 over to solve for the b variable, since it's a negative 12, the opposite of that, we're going to be adding 12. And we get 17 is our value for b. Ellen.
I know I think just for like next week, I think I know how to find the y-intercept of the charts.
Yes.
I think I figured it out.
Good. Hang on to that thought. Okay. Is this our final answer though? B equals 17? No. Our final answer is the equation in slope-intercept form, which means we take that slope that we found, that negative 2, we put the 17 as our value for b, y equals negative 2x plus 17. And the reason why we go back to putting the x and y variables in for our final answer is this equation of the line. Remember, x and y can represent any ordered pair that's on the line. Aiden, we don't want to plug in one of these ordered pairs now, because that's like a really specific point. In our final answer, we want x and y to remain x and y to show that any ordered pair on the line can be plugged into that to make it work. Okay? Alex? What's that? No, I'm not going to do any more now. All the rest of them we're going to cover after break. Okay? If you want to try it, go right ahead. But there's no homework other than con is due tonight. The football sheets are due tonight. And
Is there a new one?
there's a new one posted, yes. Week 11 is the current one. Week 11. I'll update standings.
Noah, come here.
Alex.
Football.
Okay, if you, folks, shh, Alex doesn't believe me that either ordered pair is going to work. So if we use that ordered pair, okay, the only thing that changes is now we're plugging 9 in for y. You can see our slope is still -2. 4 goes in for x, and we're solving for b. That gives us 9 equals -8 plus b. Vince, Jack, warning speak with you. Okay. Adding 8 to both sides to cancel it out gives us again 17 as the value for b. Right? So both ordered pairs are going to work. It does not matter which one you choose. Okay? All right. Have a great Thanksgiving. I will make a video and post a video for the math packet. That's how you math.
Don't forget to like and subscribe.